Hi guys, good morning. This video is the problem longest palindromic subsequence, and oh boy, this what you're going to see in this video will be hands down will be the best expression you're going to find on the internet. I'll show you from recursion, top down, bottom up, then bottom up optimized approach. Ultimately, we will reach to a solution where O of n space and O of n square time is being used. If you find anything like this or even close to this on the internet, I'm not saying YouTube, I'm saying on the internet, before 14th April 2023, just let me know down below. I swear, I found nothing like this. So yeah, without further ado, let's start with the problem statement itself. Longest palindromic subsequence. The problem itself is up till this only. Longest, which means as long as possible. Palindromic, which is a palindrome. And what's a palindrome? Palindrome is nothing but which is starts and ends like same, which means I have A, B, C, then one character or nothing at all, then CBA. So basically it can be ABC CBA or ABCX CBA. So basically start and end looks like same. If we go on from start end, then it will look exactly like same. Going same like this. And it is saying, okay, what's a subsequence? Like a subsequence is nothing but if we have that string, that vector, that array, anything, for the subsequence of that particular string will be nothing but if we delete some or no elements from those n elements without changing the order. So if we have, let's say, these n elements, so I have option, okay, I deleted, I not deleted, I deleted, I not deleted. So one quick question, what do you think, how many number of subsequences are possible? I told you, right? For every character you have two options. Either you will delete it or you will not delete it. If you will delete it, then it's gone. If you will not delete it, then it stays there. So for every character I have two options. Thus number of subsequences possible are 2 raised to power n. Thus the first very basic approach which comes in my mind is, okay, it is saying longest palindromic subsequence. I will find all the subsequences. I'll check if that subsequence which I found is a palindrome or not. If it is a palindrome, good, it's of my use case. If it is not, then it's of not like I won't consider it. But if it's a palindrome, then okay, what's the length of that palindrome? And I want to find the maximum, which means the longest length. Okay, I will find all these subsequences, which is O of 2 raised to power n. I will find if that is a palindrome or not, O of n, and just keeping that max variable to grab that max length. Complexity will be O of n into 2 raised to power n. N is 1000. Exponential will never work. Our brute force gone, legit gone. Let's think of something. I show the recursion, like a recursive code also, but as you know, okay, it's not working right now, so we will not see right now, but still I'll show you. Let's see what we can do. If we just look at this thing, okay, longest palindromic subsequence. Palindrome, if I longest, okay, I will always have that max variable which can have that longest to me, and it will bring the longest to me. But that palindrome word, can we think of something with that palindrome word? Palindrome, as I said, it is exactly the same in the end also, which means if I have a something, then in last also I have a. So if for it to be a palindrome, it should be same. For it to be a palindrome, it should be same. For it to be a palindrome, it should be same. You saw what's happening. It should be same, which means start and end should be same. Which means if I have any of that string, then I have two options. Oh, if the start and end are same, it's for sure okay. I want longest one. So if start and end are same, for sure I'll just grab that thing because I want longest. So I'll just try to grab as much as possible. So I'll just grab these two, start and end. So length added 2. Now I have to worry about, okay, what is the LPS, longest palindromic substring of that remaining part, which means B, C, C. But Aryan, what if the start and end are not same? which means, okay, start and end are not same. I change the example right now. What if it are not same? So if it is not same, then I'll just try to ignore one part, like one character, because I know it can never come in my palindrome, right? Because it needs to be same. I can just ignore that part. Maybe it will not come. I can just look at the remaining part, which means from, if it is I, then from I plus 1 to end, which means from start plus 1 to end, which means I just ignored that first character, and maybe you can see, maybe in future I saw something like, okay, B and B, it can make a palindrome. Thus, one option is, okay, I can just ignore that, and as I'm ignoring that, so like nothing I can get in my answer, longest palindromic subsequence, something I can have in my answer. It's the reason I can only evaluate, okay, what is the LPS of now BCCB? But Aryan, wait a second. You just assumed, okay, you had A here and B here, so B will make a palindrome. Okay, it's good. But what if we had something like CC? So maybe I can just ignore the end part of that. Okay, I'll just ignore the end part. Then I can just evaluate that start part. So it will be just LPS of start to end minus 1. You saw three things. One is, one case is, okay, both of these are same. For sure, I will add in my palindrome. If they are not same, so I'll just try to ignore one and take the remaining. Or I can ignore this and take the remaining. Anything which is maximum out of these two. So out of one is it is the best option. It is the best option. If it is same, always grab it, because we want the longest. But if it is not, then try removing one, grabbing the like other half, removing last one, grabbing the first half. It is the same thing which we have to do in this problem. It is how we thought, okay, what is the option we have, what we can do, what we can have, and so on. So as you can see, if I have this, then as I said, I just see, okay, start and end. If they are same, start and end are same. As you can see, start and end are same. So I just grab, okay, two characters came. I have to now evaluate my B, C, B, D, C. Oh, B, C, they are not same. So two options, either remove the start part or remove the end part. If I remove the start part, I get this C, B, D, C. Basically, the two is for sure added in my answer. Now I have to think, okay, how to maximize it. Okay, the other thing what I said was, okay, how about I removed my end part? I just get this start part. I just get it. Now again, I'll just see, okay, if the start and end are same, for sure take it. I will grab a 2, and now I will evaluate my remaining part, which means BD. Here also I can see, okay, B and D not same. For sure I have two options again, remove the end part or remove the start part. Remove the end part, I'll get this BCB. Remove the end part, remove the start part, I'll get CBD. And for sure I'll get the maximum out of these two, whatsoever I get, because ultimately I just want longest. As you can see here also, P, B, then it's same, add 2 and remaining, which became C. And for sure it's one character, so one character is always a palindrome, so it will just give me a 1. And here it is C and D, not same. Again, two options, remove the first part, remove the last part. It is how your recursion will work. Okay, you have three options at every step. First and foremost, basic standard thing, okay, if they are same, just grab it. If they are not, then two options, okay, remove the first, remove the last, remove the start, remove the end. Oh, Aryan, yeah, but it is same as recursion what we saw above. But if you see one thing, there is LPS of BD which are finding, and here also you can see LPS of BD which we are finding. You saw one thing in your recursion tree, you can see a sub problem as being repeated. Whenever you hear of something, okay, some problem is being repeated, what comes to your mind? DP, right? That's the same thing. We can see in our recursion, okay, subproblems being repeated, so we will apply memoization and we can just simply solve it. How? Let's see. If we just had looked at it as a standard recursion, how we would have solved it? Firstly, okay, it's just calling another function it is the main function which is performing our main task. What it is doing? Firstly, a very base condition. Okay, if my start and end are pointing to the same variable, then it is, let's say, A, B, C, D, C, B. If it is pointing to the same, though both are same, then for sure, right, it is a palindrome, because one getter is a palindrome. So I have to return a 1. If my start and end overlaps, it just goes, so it's of no point. It's not a valid string itself. So it just return a 0. Now, as I said, if the start and end are same, just add a 2 and try to solve the remaining part, which means start plus 1 and end minus 1. You saw what was happening. I was starting from the extremes and was just moving inside. So you saw, right? The same thing. Start plus 1 and end minus 1. If it is not same, then what else? What else? I will just try, okay, leave the left part, leave the right part. Leave the left part, whatsoever you get. Which means I'll just go from start plus 1. Start is left. I'll just leave the right part, which means end is left. So I'll just go up till end minus 1. Whatsoever I get, maximum out of leave left and leave right will be actually the answer which I get. But as we saw, it's a recursion. It has repeating the problems. It will fail. It will give a TLE. But our DP is so a simple memorization. What? Firstly, grabbing a DP array which will actually store the result of every state. And as we know, we have start and we have end. So the variables are 2. As you easily saw, okay, start and end both are changing at every point of time. Start and end. So we know one thing, okay, my DP state will have 2 variables, so it needs to be a 2D array. 2D array is okay. Okay, how? I just grab the 2D array. Very good. Where all to put? Wherever. Firstly, as soon as you enter your function loop, then before moving on to actual recursive calls, first check, okay, have you filled that particular state, which means start and end, that particular start and end, have you filled that earlier? Because if it is filled, then your DP would not be -1. If it is not -1, which means it is filled, I'll just return that state of DP. But if it is not, ultimately in the end, before returning my answer, I'll just store that in my DP, and because in future it will just help me to actually grab that value from my DP. By this, you can easily see that your time complexity will be what? O of n square. How of n square? Because of the array of DP. Because ultimately you are doing recursive calls, but how many you can do? You can do as much as your DP can store, because as soon as it is filled, anytime it is being called again, it will just return a value. It will never go into the recursive calls. Thus, because of this array of DP, which is of n square size, my recursive call are bounded to be inside n square only. And as we are using the DP array itself of n square size, so spaces of n square, your problem is solved. Legit solved. But we will still see, okay, it's a top-down approach. Let's also see bottom approach, because if we need to optimize, because if let's say I ask you, hey Aryan, optimize it, you cannot think of any optimization right now. But if you solve this in a bottom-up way, you will be able to see the optimization that can be possible. But I'm not saying, okay, it's difficult. What you saw, okay, what was happening in the recursion calls, because see, recursion is just abstracting out the inner layers. Now we just have to visualize those inner layers also to actually see, okay, what's happening in a bottom-up approach. What's happening? See, it's just a matrix which was like in the recursion which was being memoized. What was happening was we were just filling our matrix, and how the matrix looked like, it was something like this. Let's see how. I just made that thing, and you can just grab these nodes down below, because I just give those nodes so that you can just parallelly look and see what's happening. We just make a matrix. How the matrix looks like, let's see. It just starts with, firstly, we have the start, we have the end, right? We have these 2 variables, start and end. Now, one thing, very basic thing, how that matrix was being made. Firstly, I have this row. his diagonal, which is okay, from A to A, what's happening, from B to B, what's happening, from, so basically it just shows, okay, it is a start, it's the end, like, okay, yeah, what's happening, which means at any state right now, it just say, okay, from B to B, B to B, yeah, it's B, oh, it's B, from C to B. So basically, like in future notes, you will just see that is a D. So just forgive that part. But yeah, it was from B to B. Now let's say from it is, if it is saying from B to C, then it is B C B D C, B C B D C, from B up till C. It's just how my matrix is being stored for every diagonal. Okay, you know how the matrix is looking like, but let's see how this matrix is being filled. Whenever you have the recursive calls, it just goes to the very bottom base case. And what was the base case? It was nothing but when both the start and end are equal, which means when we have only one character, which means, okay, you have only one character itself, which means A, B, C, B, D, C, A. You can easily see, okay, it's just one character. One character, like the palindrome length, will be actually one itself. Cool, no worries. Now, actually, we will start the calls for this, which means AB, BC. So, AB, palindrome is itself A or B. So, longest length is actually 1. So, it's just 1, 1, 1, 1, 1, and 1. So, basically, if you just have a look here, it is a B and a B. It's a B and yeah, it's a B. Oh, so it was a BD. Yeah. So basically, it just say, okay, it's a AB, it's a BC, it's a CB, it's a BD, it's a DC, it's a CA. AB, BC, CB, BD, DC, CA. So easy see, okay, AB, both are different. So for sure, the longest palindromic length is right now 1. Cool. My pink one is done. Now I just go on to the next part, which means my one character is done. 2 characters are done. Now let's try for 3 characters, which means A, B, C. When I try to evaluate A, B, C, I just see, okay, is my start and end are equal? Which means, okay, I just need to ignore my first character, which means A, or I can ignore my last character, which is C. Then I have to see, okay, what's the maximum out of B, C and A, B? It is what I was doing earlier, right? So BC's value is stored where? It is stored at the bottom pink. You can see this cell. While the value of AB has been stored here at this point. Thus, I can just grab maximum out of the left and the bottom. I can grab the maximum value for ABC. Consider when our ABC, when I was starting out, I was saying A and C are not equal. That's the reason I just ignored A, and at one point I just ignored my C. Cool. By this, you can just easily fill this particular diagonal. Now, when it comes to the next diagonal, then again, I just see, okay, let's see this condition, which is this right here. C, let me write down C, B, D, C. Now to evaluate this, you can easily see, okay, C and C are equal. For sure, grab it. Grab means add a 2. Now evaluate BD. Grab a 2 plus evaluate BD. BD is where? It is stored just diagonally below BD. That's easy. I just grab a 1 for it. I just got a 3. I just update the value as 3. It is how you will update your diagonals every time. Next condition. Okay, it's same as earlier. I just grab this maximum out of, see, it is B, C, B, D, C. Both are not same, so one day I just remove this, and on other thing I just remove the last C. I just grabbed, okay, it is the left thing, it is the bottom thing, maximum out of left and bottom, it is 3. I just grabbed the 3. And same it goes for the next diagonal, same it goes for the last diagonal. In the last diagonal itself, it's exactly A, B, C, B, D, C, A. A and A are same, add a 2, remaining string is this, which is diagonally this string, which is 3, so we got answer 5. Ultimately, I just evaluated my whole string A, B, C, B, D, C, A, and it is, the answer is stored in the last top right cell, and that is will give you the longest palindrome. It is as simple as that. How? See, you saw what happened. We started from one character, then 2, then 3, then 4. Basically, we are increasing and taking help from the previous result which we are grabbing off. Okay, if I just remove that, or if I remove both the characters, then I just get this. As simple as that. It's the same thing which we have to do. I just start for every length. So basically, ultimately what I want is a start and an end. So you can just easily have the start and the end variables. You can have the length in the start variables. You can have the length in the end variables. You can have anything. Ultimately, what you want is a start and an end. So it is ultimately to you that how you write the code itself. Okay, it is start and the end. Cool. It is length and the start. Anything. So I just grabbed, okay, length and the start. Length is very same. Okay, what length I want. Initially, I'll start with one length, 2, then 3, then 4, then 5, then 6. Okay, like this. I just grab the start from starting itself. With this, I can just have, okay, if the length is 1, so start and end are both same. Length is 2, okay, end is just start plus 1. It is how I will just get the end of my every string possible. Then ultimately, very base case, okay, if the length is 1, then for sure the answer is 1, and I can just move on. But now the actual fun starts, which means if my start and end are same, as I'm evaluating a string of start to end, if my start and end are same, then I'll just grab my 2 plus, okay, what is start plus 1, end minus 1? It was nothing but for this particular string. Let's see, let's see, yeah. For this particular start and end, my start plus 1 and end minus 1 is this. Start plus 1, end minus 1. As I showed you guys also, diagonally just bottom, if it is same. If it is not same, then simply from down and from left, I just grab, okay, what is the maximum? Because it is nothing but start plus 1 comma end, and end start comma end minus 1. As you saw in the recursion also, it was exactly the same. Start and end minus 1, start plus 1 comma end, exactly the same, which what we are doing. And ultimately, I just every time store, because it's actually not a memorization, so every time I have to store in my DP array. Ultimately, what I told you, I have to return the answer from the top right side, because it is storing the result for the complete from 0 to n minus 1, from start to legit end. It is storing my actual result. Same that time complexity of n square, because actually we are iterating on the whole DP arrays. You saw, right? Diagonal. So half of the DP arrays was being used. So O of n square. Space is also O of n square, because you are using a DP array matrix of that n square. But did you see one thing which can optimize this? Just pause the video right here. Just see what you can optimize. You saw what was happening when we were just iterating on those diagonals. You saw, is it actually required that, okay, for this value right here, I just only required the left, down and the diagonal cell in the all cases. If it is same, if this particular cell right here has the same characters, then I need the cell which is diagonally below. If it is not same, then I need the cells which are left and bottom. Ultimately, for the row to evaluate, the orange row to evaluate, I just need the green row and the pink row below. Which means if it is the row I have to evaluate, then I just need the previous row and the previous row. Which means this row and this row. If it is the row I want to evaluate right now, I want this prev and DP. If it is that, I want this DP, let's say DP, or it is a DP prev. With these two, I'm not concerned about the what has gone. I just want last and last to last. That's it. It is how we can optimize our answer, which means, as I showed you here also, for this orange one, I just need this green one and this pink one. And as we are iterating on those diagonal wise, thus it is how it is being stored. Green is stored one time, pink is stored one time. It is how we can just optimize our space. Earlier it was O of n square. Now I can just simply use two arrays, a DP and a DP prev, which will actually store me, okay, O of n and O of n for one DP and for one DP prev, which will actually give me result from O of n square space to O of n space. Lovely, right? With this you can see space You see where the space has gone. It just legit reduced. Let's see the code particularly. It's pretty easy, pretty easy. If we are, see what we can do. Okay, we're just starting from bottom, going up, finding the, we're starting, okay, and we have the start, we have the end. Firstly, we just go on to one character. Very good, very awesome. Then if we right now, if we are at a DP, and we, as you know, we are going from start to end, and start is from n-1. So we are moving like this. We are moving like this from bottom to up. We are moving from bottom to up. As simple as that. So my DP is moving like this for sure, right? Cool. Then first very base case, okay. If it is just a one character, then for sure the DP value is 1. But now I have grabbed my start and end. As usual, as standard as what we saw previously, we have grabbed the start and end. Just remember one thing, how my DP is being moved. My DP is being moved from bottom to top because I'm just grabbing my start from the n-1 to actual top. And with this, what will happen is, okay, if I'm just evaluating this, my previous DP was just before it. Now I'm evaluating my DP right here, right now. Okay, it is 3, which I'm evaluating. So firstly, if it is same, then I just grab my DP previous of n-1. If it is end, n-1 is just below. So to grab this DP, it is DP of this. Okay, it's very cluttered. This DP of this end is nothing but DP of prev of n-1. Because see, it is DP of prev. I'm just overriding my DP of prev every time as I go forward, like this. Cool. Then it's DP of prev. It's n-1 because I'm moving up. So n-1 end, it is how it is going. Okay, and in the next iteration it will be n-1, it will be end, like this. Cool, no worries at all. I'll just grab my DP prev of n-1, which is the value right here, add a 2 because it is same. If it is not same, then no worries at all. Just grab this left element, which is nothing but DP prev of end, DP prev of end, or the bottom element, which is nothing but the DP of n-1, DP of n-1. And that's how I can just grab this DP of n, because I'm just have to fill that DP of n every time. It is this DP of n which I have to fill at this time. And ultimately, as I go on to the next end as I go, as you see, I'm just going end like this. If the next end I go, I just need to actually put my DP in DP prev, because next time I'm going to update my DP and would be needing that DP prev. Ultimately, I just have to return my DP of n-1 as I was returning the last top right cell of that particular 2D matrix. That time is nothing but O of n square. As you can easily see, it is the same thing which you were doing in your old problems also. It's just that space will be now O of n, because now you're using only DP and DP prev. That's it. I hope that you guys got it. Every code for recursive, top down, bottom up, and also bottom up optimized, which is O of n, all are down below. I hope that you guys liked it. If yes, then do the like button. I know the video has gone pretty long, but I just want it to be the most comprehensive video on the internet for this problem. In this, you see 4 approaches down from scratch. If interviewer asks you this, and if you tell him, for sure his selection is for sure, it's confirmed. For sure. And without further ado, let's start, but yeah, let's end this video. And I hope that you guys liked it. See you in the next. Goodbye to you.